We're done with this stuff up here.
Yeah. All right. All right, so before you get too overconfident in seeing some of the rough ideas of our peers here, who thank you very much, that is not easy to do. I know you're going to make it even better. Right now it's good.
Make it good, make it better.
All right, so what about other groups? We need to check in. I need to see and hear what ideas you currently have. As rough as they are, I'd like to hear what your other ideas are. So even if they aren't what we've talked about before, or what you want to do, or what you think is possible, let's throw them out there. Yes, Sheila?
So I have kind of two ideas, but they're not like kind of the same concept, that when you try to remove graphene from something, it can crumble on itself. So I think either to make like, have plastic either stamped, like stuck on something and design, you know, a way to like kind of pull it off. Or from the other part of using graphene, have there be plastic in like a liquid and they have to get that out without it crumbling completely out. And I think that the best way to kind of mimic graphene would be saran wrap. It's sticky on itself, and that's what it's at.
Okay.
Sounds frustrating.
Yeah. Any other comments? Don't?
So what kind of things would they use to remove graphene besides food? Or like, what's the range of design?
Well, the problem is tape wouldn't keep the structure of the graphene together, so they'd have to go up with something else. Like, probably would use like something more solid, probably like a stick or something.
Still rough. Okay. Any other comments?
How are you going to see the structure of the graphene? How is the structure of the graphene seen?
I was going to use kind of like just a saran wrap as like the mimic of graphene, because they're both still.
I got it.
You might be able to spray an adhesive on the saran wrap. Let's say you put it down and you spray like a little, like they used to have those spray cans of adhesive, like for tablecloths or different things like that. You could spray it on the saran wrap, and then if it touches itself, it'll automatically grab. Like regular saran wrap sometimes won't. Like it'll touch and just bounce off. But if you put it like, hey, you're set, you have to get this right. But what stops them from just using their hands and grabbing the corners, two and two, grabbing the corners and pulling it up together? I don't know yet. Okay.
The parameter, you're not allowed to use your hands.
Yeah, probably.
Is the design challenge that they're creating like a tool to get it out?
Yeah.
All right, next. Elsa, why don't you talk about yours?
Okay, so for mine, you guys remember that I have a bunch of tennis balls and like all different kinds. I'm going to keep using that idea to mimic water. So instead of using actual water, I want them to think about the actual molecules that are in water, and that there can be things in our water that might be harmful to us, or things that we might want to get out for a variety of reasons. So 2 weeks ago we did the filter one, which you guys tried. And then this week we're going to do an extraction method. So I'm basically going to have a box that is full of all of these things. And the goal is to get out all of the nanoparticles, which is the bad particle that we want to get out. And I'm going to give them freedom on how they want to do this, but I'm going to lead them in the direction of making a scoop. So like if they want to make a fishing rod type thing, they can. But my prototype, which is going to fail, is going to be like a scoop design, so like try and get it out, and then like shake off the bad stuff, and then extract what they want out. Yeah, they're shaking off the good stuff, so it goes back in the water, and then they're actually taking out the nanoparticles. So the design part is the actual scoop itself. And then, so it has to be strong enough to dig through everything. It needs to have some way of catching just the nanoparticle, whether through size or through, like it's the, right now I've got them covered, and, well, not covered, but they've got patches of Velcro on them. So they can use Velcro as like an adhesive to get just those ones out. But the catch is that there are also other particles within our water that also have some Velcro on, just like maybe a bit less or in a different spot. So they have to kind of think about all of these different things.
Are you using water, or is it
No.
just the box?
Yeah,
Okay, got
so
it.
the box is water. So
Got
during
it.
my presentation, what we're gonna do is we're gonna go through every single thing in the box, which I've got a representation of, you know, things that can be normally in our water. So our, like, the big tennis balls are like clay particles, so it's bits of, really tiny bits of soil that are in amongst everything else. And then we've got like regular, you know, like sodium, which is like salt, and then, you know, a couple other different things. And then there's the nanoparticles, which are these really tiny things that are in amongst the things.
Talk about your demonstration during your presentation.
Okay, so, how do I remember it? So basically, we want to try and get across the idea that like water that they drink out of the tap is not pure. Like it's not just water. And it's something they might not think about because, you know, tap water looks like the eye water. It looks exactly the same.
Distilled water.
Distilled water. You guys don't have to. So the first part of our presentation is going to be first part of our presentation. We're just going to like take tap water from like the sink by the bathroom or whatever and show that it can actually like conduct a current through it. So we'll like light up an LED just using that water. And then, so it's like, okay, so regular tap water will conduct electricity. And then we move on to our second part, which is we use distilled water and show that it doesn't conduct electricity because there are no ions in the water. I'll try and like make that easy to understand. And then we'll, to that distilled water, we'll add salt and then show that now it does actually conduct water. So there's salt in the water, and that's changed the property of the water. And I lost my train of thought.
So you'll lead into the design challenge by
Yeah.
asking the question, what happens now that we have a mixture
Right.
of salt and water?
And we want it to go back to not being able to conduct electricity or not
What
have
if we
this
just wanted to
property.
grab certain particles out?
Right.
Like you were going to have different flexibility.
So we were talking about, like, after we add salt, also add, like, sugar, and it still dissolves, still can't tell if there's a change. Add something else that also dissolves, doesn't show any change, but now there's more stuff. So then, at the very end, we'll say, okay, well, what if we want the sugar in there, and we want whatever else, but we don't want the salt? What do we do now? So then, we'll kind of reiterate what we did 2 weeks ago with, like, well, last time we tried a filtration technique to get out certain things out of our water. Now we're going to try extraction and then design challenge.
So there's some interesting things here. Anybody have questions, comments?
Well, so the analogy that water is sort of pure water with a lot of particles in it isn't necessarily a good one. We've got to be careful that we aren't sowing the seeds for problems in pre-chemistry. So if something's in a solution, well, I can make the holes as small as I want. It's still going to go through my filter and not filter out the substance because it really isn't a particle, it's in solution. So let's just be careful about, if you're truly just talking about different sizes and shapes of particles, then put sand and, or that
Yeah,
kind
so
of
I've
thing.
got like clay particles.
But I wouldn't use salt because, you know, it dissociates as ions and it really, it's a little more complicated than just like your analogy, which is a bunch of balls all in a thing, and that's really not a good analogy for what water is with salt in it.
Yeah, because I mean, yeah, there is that. But in the context of their understanding of like nanoparticles, which is a particle that's very small, like the concept of it being dissolved or essentially dissolved in water because it can't be seen, I think that's valuable enough
Does nanoparticles, like nanosilver, does that actually create a solution with water, or is that just part of it?
It's a solution. So it will, it's essentially colloidal, but it does settle out eventually.
Interesting, it's more complicated.
Yeah, so it's,
We'll need to talk about this.
but I think, I mean, as far as like the salt is concerned, like things that go in the water change its properties. That's really important. And from there, if we add things like, you know, like I could steal some clay from lab and show that it doesn't change the water at all if I use a small enough amount.
All right, we're
And
gonna
then-
keep moving on, Nelson. Natalie, did you have your hand up?
Yeah, sure.
Go
I
ahead.
don't really have much though.
Go ahead.
Basically, so.
Maybe tell them what you did last time a little bit, because you
Yeah.
originally showed the group on stuff like velocity.
Yeah, so I had the velocity presentation and we completely ditched that idea, so that's what I'm trying to like revamp for next week. But I fell back on another project that I've been working on and kind of got through. So, in the lab we make kind of like these little spring scales, so we were having them build a spring scale that could tell the difference between a ping pong ball, which was cancer, if I remember right, and force applied by cancer, and then a large marble that was kind of heavy, and that was their red blood cells. So they had to build a scale, which we helped them with rubber bands and cups and those sort of things, and then added in when they got that, they added in a small marble that was kind of an intermediate weight to represent intermediate force, and they actually did pretty well with it. So, trying to go back to the velocity one for next week. Originally, I was trying to build these scales kind of vertical, like upright. But I think I'm going to try to build them upside down this time and apply force with wind and measure different angles of some sort of structure, or I don't know yet.
We're still working on it. The reason we were talking about it is those velocities would have a little sensor for different things, like a place for molecules to attach to, right?
Sort of.
Oh, yeah. But basically, you had to have the velocity because you needed to calibrate what kind of force these guys were dealing with, right? So that's the idea right now. Okay. Yeah.
We need wind, we have the blower, and we have those spring scales. So the blower doesn't provide a whole lot of force, that makes it skip everywhere with the spring scales, but it's a good little like attachment thing and make it going through the forces.
I hadn't considered these springs at all. They're already in sensors, so I'll just let them.
All right. And Ben, what about you?
So what I was kind of thinking about is, so the last time I did mine, they were like catching drugs in a cell, which is like the cup. So it's open, which is not like what happens. And so what I was thinking is that I would have like a tub full of water and kind of close it, maybe put a hole in the top. And so the drugs, the packing peanuts, they need to package in such a way that they would sink into the cell, the tub of water, because the packing peanuts will float and whatever. But I think the issues I kind of raised is like what kind of given will make that happen, and like once they do it, kind of like where do I go from there type of thing. Because it's like basically what I'm doing, I'm asking is just like to wrap it up in a way such that it'll be heavier than like the buoyancy of the packing peanut. And so I don't know.
Crazy stuff. Yes, John.
Just to bounce off your idea, we can make it a challenge by having them, so instead of the goal of the packing peanuts coming all the way down, they would have to like reach a certain depth of water, and maybe that would be a way to extend it.
I think that's what
Or you need a pretty deep thing of water to be able to change the density, you know.
it's really, really tiny.
Is there any way you could, like in between the cup at the bottom and the thing at the top, like have some obstacle that they have to design a way around? Like it has to be smaller than this, and it has to go straight down, or it has to go. like they have to aim it somehow? Like would that be?
Maybe, because I was really just thinking like a hole in the tub, and they have to like, just to give them a size constraint. And so it's kind of like the cell doing like endocytosis or whatever. I wouldn't be explaining that, but like, I can find like this cells uptake things by making little holes and stuff like come into them. And then they close that hole, and that's how cells like do their thing.
Okay, cool.
I don't know.
All right, so we've got one design challenge left. And it sounds like we still need lots of work. They're tough. It's, who thought that they would ever make one design challenge, let alone 4, right? Okay. What has been, so you've done 3. What has been your favorite design challenge that you've done and why? Nate?
This previous design challenge, I don't think many of you know what it is. So essentially what I had them do, I gave them all DC motors with a wheel hot glued to it. And there were 2 strips of aluminum foil that were the tracks. And so they had to build a car out of various materials that had the wires of the DC motor dragging behind it, so that when they set it on the track, it would complete the circuit and power the motor, and they would shoot it forward. And it was just, a lot of them, it seemed like magic. And they were really surprised and awed by it going forward, just by them putting it on it. It was really cool to see them all trying so hard to figure it out.
Yes, John.
I think Ben's challenge with the packing implement was my favorite so far because it was, the challenge was good in that it was simple to understand, and but then also the range of designs that you can get and the level of creativity was so great, and there was never a point where they would like reach a maximum point and they'd be like, okay, I've completed. It's like you could always do more and more, and so I think that was a really good design, and that you walk into class and just notice brutality. Every design was just so different, and I don't know, I just thought that was really cool.
We have design differences. We have the magic of science. What's else? What else?
I think last week we had a good discussion. We did discussion sheets, like I think jackets. I think that's what you guys have been doing. And we had them all answer, and they were like really super quiet for like 3 minutes, which was kind of crazy. Like the room was silent. And then we were like, all right, let's talk about our answers.
What was your guys' design challenge? Talk about that first. Nobody knows. Teamwork right there.
So, in the lab, I worked a lot with soil. So we taught them like different grain sizes have different properties, and we made a Darcy tube sort of, which is a tube you fill with soil, and you run water through it. And we just had them learn about different ways of how fast the water would go through, and different sand properties and soil properties.
Yeah, it was very cool. All right, in the discussion part.
Yeah, and so then we brought them back and we kind of talked about it and talked about their answers. And they had like a couple things just like kind of backwards from what they learned, and we were able to be like, oh, like, you know, you're really close, but actually it's this way. And they're like, oh, okay. So like this week I was able to see them leave the classroom and you really understood what we were trying to get across to them. So I was like, all right, we did a good job this week.
Educational value. Yeah, definitely. We got a couple groups left. Yeah.
We got our best participation the second week, and that was a lot of fun. This week, we had,
Which was the second week? Was that yours?
yeah,
The first micro cap week?
we actually we had good participation, but we were the first one too, actually.
Yeah, I think your first 2 weeks were good.
Yeah, but this week, I don't know, we got less, so that was a little disappointing. But yeah, I liked both of those a lot, and I don't know which one I actually liked more, but they were both good. They were both
Why
not,
were they good?
well, they weren't particularly open-ended, but they taught the concepts really well, and they were fun, and everyone enjoyed it a lot, and I think learned a lot.
Okay, that was good. So, enjoyable. We got 2 groups left. Owen?
I really liked this last week's Like they kind of. I know it's so funny. So, but because I think it's a cool concept of making something huge and visible. And with that one,
It's not quite invisible.
Well-
It's invisible to a detection system.
right?
He's the technical one, and then
I like it because that one, well, okay, so they mainly use tinfoil and covered plain up, which fine. But that one, there's a lot of different ways that could have done it. That would have
absorb. I don't even know. Material that absorbs.
yeah.
Like you didn't get anybody using construction.
No.
I got
Okay.
some.
You got like.
Because I started pushing that one more. Maybe you guys-
They try to mix it both, like, most of the planes ended up with paper and,
If you want to talk about somewhat, I mean, almost like it was open-ended, represented your research. Did you have your hand up, Josh?
Yes, I was gonna say, I really like Molly's first one because I thought it was very, very challenging and open-ended, and I wasn't sure how the kids were gonna receive it at first, but like seeing like the kids be really creative and actually solving the problem was really cool. And I thought it represented Molly's research pretty well too.
Anybody else comments? Okay, well, so this is the first time this class ran, right? There's some things that I have to comment on that I think are great, like milestones, different things. I think that if I am looking at your design challenges, it's tough to know all that there is because I wasn't in all of your classrooms to see which ones are open-ended and which ones really represent the research. I think some do more than others. How about that? Some of the projects you almost can tell are more open-ended than other projects. And that's really what we were shooting for. So, but that's also what we're trying to learn how to do better. So how do you think, like, could we improve learning how to do an open-ended design challenge? Like, do you understand yourself the open-ended design challenges around you better? Like what it means to have an open-ended design challenge as well?
I think that I understand what it means to have an open design challenge. I definitely learned what it is. Because just even looking at my brainstorming over the summer, I met with Dr. Castro, and maybe like half of our meeting, not only now meeting with him like every 2 weeks, and we would just brainstorm, and I think we came up with like 10 ideas, and I don't think any of them are open-ended, which I wasn't aware of over the summer, really. So I think that I definitely learned that, but then I think it's a really tough balance because you've got to balance, you want it to be open-ended and display the research and teach concepts that they'll be able to understand, which is also hard. And then add a wow factor so that they get excited about it.
And use cheap materials.
Yeah, so I think balancing all those things, if you want it to be really open-ended, it's kind of like, okay, well, let's balance it with everything else. And ideally, it's all of those things, but sometimes it's like, let's make it a little less open-ended, but it's going to represent the research better.
Any other comments? I'll go for Joe first and then Elsa.
I think when we did create a design challenge, knowing what kinds of designs that the kids should be making, I feel like that restricts it. Because we think that there can be more, but I feel like a lot of times the more successful design challenges, I actually don't even know what could, like I have an idea, but it's not as clear. Like this past design challenge that I did, it was a good idea, but it wasn't as open-ended because I kind of predicted what they could be making. And so I think that anytime you can really predict what they can make, that immediately makes it not as open-ended as it can be. Like with Ben's, I have an idea of what they can do based on materials, but we weren't creating the design challenge and gearing it towards a certain way so that we can be like, hey, make sure you do this or do that, because that we're like basically trying to force them to, so I think that's what.
Awesome.
I was just gonna comment that, like, at the very beginning of this and over the summer and everything, I really struggled relating my research to the design, to like a design challenge, because I don't know, it seemed like over the summer I really didn't do very much of designing at all, kind of just follow procedures. So, but it's interesting, like, once you are involved in different design challenges, you become more aware of like what you can do. Like, you're like, oh, if I think about my concept this way, then maybe they could do this. And then, but I think I agree with Joan, like, I feel like the less of a concrete idea you have of how you're gonna do it, the better it is, because you can genuinely support their ideas and wanna see where they go with it, rather than being like, well, that's not like my design, so it's probably not gonna work very well. So it's kind of, like, I felt like with my first one, I knew that there was a lot of different things they could do, but I thought that the idea that I had done and I had worked on, that was always in my mind. So when I was helping them, it was always like, oh, well, maybe you should try this. And it was like related to my design, because I didn't know if theirs was going to work, and I was trying to help them improve. So I think that having a less concrete idea makes you more prepared to examine all the possibilities, including their design.
Howard, can you do me a favor and make sure that camera's running again, just for okay, anybody else? Jack?
It's easier once you have examples. After the first week, we had a lot of examples, I think, of everyone else's, like, design challenges and which ones work particularly open ended. You can kind of look at that and then say, okay, so I might kind of do that type of thing. Like, I don't know. I feel like before I didn't have a fantastic understanding of what an open-ended design challenge actually looked like in practice. Like, I knew that it has to be open-ended, I know what that means, but we hadn't really seen any. I mean, we saw yours, and that was kind of
one
it.
example.
Right.
I understand. One is not like done.
And then, yeah, we kind of like, we tried to look at the iridescent website, none of those were really open-ended, so it was hard to.
There were some, but I only had to look at 3.
Right. So it was tough to think of how to make an open-ended design challenge, but then once we had a bunch of examples to look at and say, okay, that one is really open-ended, then it's easier to think of your own open-ended design, I think.
Anybody else? If you were a kid and you could have picked any room to be in, other than your own, which room from the talks that we've had up to this point would you have wanted to be in and do which challenge? Write down your answer, or do, like, memorize it so that when we have everybody say the same thing, or if we say all different things, nobody's going to feel bad. Make your decision, okay? Have it in your mind. This is where you would go, okay?
Can I like do 1 week in one room and 1 week in another?
Well, you can give a first place and a second place, but you can't give, like, you can't be at 2 different places. Okay, all right, Nate, go ahead.
So, I think for my first one, I really liked Ben's world, the thingy with the peanuts. I just think that had to have been a really cool thing to look at. Like, just to see them flying all over the place and then stick your thing in and then have it catch it. I just thought that was really something I've never seen before. So, and it kind of reminded me of the graphic monkey thing.
Yeah.
I like that a lot. And then, are we gonna do?
Sure, go ahead. Just do the second one real quick.
Yeah, and then I really liked Roland's radar. I think that sounded like a really cool idea as well. Just because I like stealth technology. That's always fascinating.
How many people would agree with Nate? Okay.
Oh, I agree with
Yeah. All right. Who wants to say something different? Josh.
For a second, I was gonna say Randall's. What were your 2 again?
There's the water sprinkler system and the system.
I like both of those actually. So.
Okay. The water sprinkler system. Why?
I don't know, it sounds cool.
Okay. That's all right. Other people?